Consider the real numbers m and n. Prove that if m is rational and n is irrational, then m plus n is irrational. So what we're going to do, we're going to, this looks like an if and then. So if m is rational and n is irrational, then m plus n is irrational. So what we do, we're going to prove this by contradiction. We suppose that the conclusion, that the opposite of the conclusion is true. So the negation of the conclusion. So we're going to assume that everything in the setup is the same, but we're going to suppose that m plus n is rational instead of irrational. So we're going to attempt a proof by contradiction. And what we're going to do, so we can write assume or suppose m is rational. Suppose m is rational, n is irrational. So that's everything that we were told already, but and m plus n, we're going to suppose this is rational. We were told it was irrational. Okay, so what we're going to do, we're going to show that in these conditions we have a contradiction. We're hoping for something that's impossible to be true. So if the left-hand side and the right-hand side of this thing show an obvious contradiction, then it means that this situation isn't true, hence that the original situation must be true. That's what we're trying to do. So let's see how we get on. If m plus n is rational, think what a rational number means. All it means is it can be expressed as a ratio of two integers where the bottom one is not 0. So m plus n equals sum p over q. P and q need to be integers. Q can definitely not be 0, because if you're dividing by 0, well, that creates something undefined, not a nice rational number. Another condition you'll sometimes see is that they shouldn't have any common factors other than 1, but it's not a deal breaker necessarily. It just means it's not a simplified fraction. So that's if m and n is rational. So that's the way we're going to write m plus n. We also need to write a similar expression for m. If m is rational, so we will say m equals, well, we're not going to use p and q, we've already used those, so we'll say it's sum r over s. They both need to be integers. R and s need to be integers, and s cannot be 0. S cannot be 0 or it wouldn't work. Right, so now we're going to just write down what we know. So we're interested in m, n, and m plus n. So m plus n equals m plus n. And we're going to write our m as r over s. So r over s plus n equals p over q. Right, so we're going to show that this gives us a contradiction. So let's see if we can just get n on its own. So this would mean n equals p over q minus r over s. Okay, so what we're hoping to do, we know that n is irrational, so we are going to show that this right hand side must be rational and the left hand side we know it's irrational. We've defined it as such. So n equals, this is going to be ps minus qr over qs. Right, now if you look at this, well, ps minus qr, well, p is an integer, s is an integer, q is an integer, r is an integer. This top line is definitely an integer. And this at the bottom, qs, is also an integer, and it's non-zero because we've already said that q is not 0 and neither is s, so how could qs possibly be 0? So it's integer over non-zero integer. And if you've got an integer over a non-zero integer, well, that's a rational number. Right, so we have irrational number, which is n, equals rational number. This is a contradiction. Which means that n plus n must be irrational. Okay, so we have proved this thing by contradiction.